So I'm really hoping that I can keep the third lesson in this series shorter. All I really want to do is practice a couple of problems. The first thing I want to cover is how do we actually, so the last long video is all about what the inverse of a function is. In this video I want to talk about, so how do you find the inverse of a function, right? So suppose that we've got the function f of x. There we go with the green marker starting off. F of x is, suppose we do something like x cubed minus 5, right? How do you find the inverse, right? And on the one hand, I could tell you how to do it. I could just tell you switch x and y, solve for y, yay, you win, there's the inverse. But I want to take 30 seconds to explain why that makes sense. In the previous video, we talked about the fact that the inverse just switches the input and the output. It makes the output of the function the new input, and all of the inputs those new output values. Right? So it would make sense that to find the inverse of a function, you could simply take your function, rewrite it as y equals x cubed minus 5, and then sort of understand, like x is the input, y is the output, so if you wanted the inverse, just switch them. Just make this say x equals y cubed minus 5, and in some sense, this right here is a statement of the inverse. Right? Understand, and this is actually kind of different. This is actually kind of strange. These two lines here are not equal to one another. Like, they don't mean the same thing. Above this line is the original function, and below the line is the inverse of f, right? In other words, below the line is f inverse. So all I need to do at this point is actually find what that inverse function is, right? So at this point in the problem, what I really need to do, and I actually kind of like the idea of sticking with a different color at this point I now need to solve for this y. So I'm going to do that by moving the 5 over. This is x plus 5 equals y cubed. And then my last step in solving for y is getting y equals the cube root of x plus 5. And then because below the line is the inverse, when I rewrite this, notice in the beginning I started with f of x and I changed it to y just to sort of make this all easier. Then I switched x and y. At this point, when I switch the y back, it's not f of x anymore. I'm below the red line, which means this is now the inverse of x, the inverse of f, which is the cube root of x plus 5, right? So in a very simple sense, if a problem asks you to find the inverse, all it means is switch the input and the output. Switch the x and the y. Switch them around, solve for the new y, and this thing is your inverse function. While I'm here, I did want to show you one other thing. There is a relationship between the original function and the inverse. I'm going to pause the video here and bring up a picture of this. So what I'm going to do in just a minute is I'm going to put up a graph of this, the original function, and this, the inverse, and we're going to look at what the relationship is. And like magic on the screen, things appear. What I've done here is I graphed a few things. First of all, I graphed the original function in green, right? So here's this cubic function, right? Then I graphed the inverse function, which was a cube root function over here. And the last thing I did was I graphed the line y equals x through the middle here. And what you should see here, what you've seen in classes before, what we've talked about before, is this idea that when you take the inverse of a function, it reflects across the line y equals x. So if you imagine that this line y equals x is a mirror, if you had the original function here, its reflection would look like this, right? So when you've got a function, you can find the inverse by switching x and y and solving for it. If you've got a picture, you can find it by kind of reflecting across that line, if that makes any sense. Another thing you'll notice here is that any point on the original function, like say for instance this point right here, which is 2, 3. If you look on the inverse, will be 3, 2. If you take this point down here, which is 0, negative 5, that means you'll find negative 5, 0 on the inverse function, right? If you take, let's see here, what's this, like 1, negative 4, you'll also have negative 4, 1. If you've got a picture of something, you can always just switch the x and y coordinates and graph all those points to come up with what the inverse is going to look like. So that's sort of the first part of this video. The second part I want to look at is how we deal with evaluating inverses of functions. So I'm going to switch to a new slide, and we're gonna take a look at this next kind of problem. So here's this other example I want to look at. Suppose that you've got this function f. F of x equals x cubed plus kx minus 20, and f is 1 to 1. Find the value of the constant k if you know that f inverse of negative 4 equals 2, right? And I sort of want to explain the easy way and the hard way for this problem. I feel like the hard way is for us to look at this and understand, oh, this means when I plug negative 4 into the inverse, I get back 2. That's not the hard way. That's just a point, right? The hard way to do this problem would be to say, oh, so let's find the inverse of this function, and let's take a minute to appreciate how bad that is, right? You'd say, okay, y equals x cubed plus kx minus 20. Now let me just switch x and y. X equals y cubed plus k times y minus 20. And you're like, now I'll solve for y. That sucks. Like, I'm not going to be able to solve that for y, right? And so what this relies on is it relies on us understanding even more deeply what this means, right? If we know that f inverse of negative 4 equals 2, we know it means that when you plug 4 into the inverse, you get back 2, right? But if this function is 1 to 1, it means that the inverse is also a function. It means that I could switch this around. Effectively, this statement right here means the same thing as me saying if you plug 2 into the inverse, if you take what used to be the output and make it the input, then the output will be what the input used to be. And I'm sure that sounded confusing. You might want to listen to that again, or just think about it again. The whole point of the inverse is that it switches inputs and outputs. Right here, this is the input, this is the output. So when I go back to the original function, the output is the input becomes the output. So what it means is that I can take my original function here and say, okay, f of x is x cubed plus kx minus 20. And now when I plug 2 into this, when I plug in 2 cubed plus k times 2 minus 20, it should be equal to negative 4. And now this should just be an easy thing for us to solve. Negative 4 equals 8 plus 2k minus 20. Let's see here, the 8 and the minus 20 will combine here to give me negative 4 equals negative 12 plus 2k. Adding the 12 over, you'll get 8 equals 2k, which means k is going to be 4. And there you go. There's your answer to the problem. What it all boils down to is just this idea of us understanding that when they tell me that the inverse of negative 4 is 2, if it's a 1-to-1 function, it means when you plug in 2, you're going to get back negative 4. What it means to be 1-to-1 is that we can do things like that. That's the end of what I have to say about this. That's the end of the review lessons that go into Chapter 5. Everything from this point going forward is going to be new stuff, is going to be calculus stuff. So I hope you do well on the B assignment, and I will see you in class.